Good morning, everybody, and welcome to day two of day two of the UFAW conference. I'm Birte Nielsen. I'm research director for UFAW, and I will be chairing the first session and opening this second day. Just a few reminders. You heard some of it yesterday. To access the Wi-Fi, the network name is Porto, and here are the usernames and the passwords. You probably all know it by now, including the hashtag for any social media that you would like to send out. Just a reminder that photographers and videographers will be filming or may be filming, so be aware of that. And if you need an attendance certificate, these can be picked up from the reception desk once you have attended. For the people online, they were at the posters anyway. So today, the posters, the second half of the posters will be up. There will be the posters where the first author's surname starts with K to Z, and they will be presenting today around lunchtime, and after the lunch, there's a poster session. So please take your time and have a look at the posters. And at the very last session today, we will have a split session. So there will be a session in here, and there will be a workshop. The workshop is a little bit difficult to find. We probably will have somebody leading you there if you want to join. It's a workshop on animal welfare as a profession beyond academia, and it has been inspired by a number of people who have thought about leaving academia for other things, but have been a little bit in doubt of what to do. And so what we're going to do is 3 people are going to present their own experiences of flipping from active research into something else, and then we'll have a discussion afterwards. But we will all come back here at the end to join everybody for the closing of the conference. But for those of you who do not want to go to the workshop, there will be talks here as well. And just a reminder that UFAW publishes a journal. You heard a little bit about it yesterday. It's the longest continuously published animal welfare journal, and we have now gone open access for a year and a half now. I just wanted to repeat this because I wanted to draw your attention to the sort of overarching subject, I suppose, of this conference has been a little bit of focus on wildlife welfare. So we have made what is called a collection. It is what in the old days would have been a special issue that would have been bound with papers on a specific subject. And now, because everything is online, we now have a collection on wildlife welfare, which means that you can go into the journal website and click on the collection, and all the papers on wildlife welfare will be there and accessible to you, even from before we went open access. So. And the editors are here. I am joint editor-in-chief together with Hugh. Steve Weddle is here as well, who's our editorial manager, and Katie Henderson, who's from CUP. So come and talk to us if you have any questions about the journal and about publishing with us, or indeed reviewing for us. And a reminder again that UFAW is funded solely by donations and legacies. So please support us if you can. You can become a member or you can donate. And if you would like to become a member, you can talk to any of us. Ailey is somewhere, probably in the reception, but right outside the door, go and talk to Ailey about membership of UFAW if you are not already a member. And we also want to thank our sponsors, Charles River, who has donated money to help us run this conference. And now we will start with session 5. And I think I do have a coffee break slide here, which I'll just skip. And the first speaker today is Charlie Burns, and she is going to talk to us about boredom in ferrets.
Thank you. Thanks so much for organising a great conference, and thanks for inviting me to speak today. Yes, so I'm going to be talking about boredom as a sort of limbo state between sleep and stimulation. And I'm sorry to all of those of you who are jet lagged or online from a different time zone to be talking a little bit about sleep, but anyway, hope you'll bear with me. So boredom is a welfare issue because it's really unpleasant, especially when prolonged and inescapable. I think for many of us in our busy lives, boredom almost seems like a privilege when you can stop and get bored. But for captive animals, it's no privilege at all. And it's a particular emotion that is caused quite uniquely when stimulation is not sufficiently varied or relevant for animals to be able to maintain their optimal arousal level. So in the 1960s, Berlin talked about how bored individuals, humans or animals, are in a state where they're not tired enough to sleep, but the level of stimulation that they perceive is also not sufficient to keep them as wakeful as they desire. And of course, captive conditions can be very monotonous. So chronic, inescapable boredom is a real risk for captive animals, unless we can provide sufficient stimulation. And I'm going to come back to that statement at the end of the talk. So how can we tell whether animals are bored? So in 2017, I suggested that you get these sort of two polarized sets of indicators, which can be behavioral, which I'll focus on, or physiological. But you get a sort of set of arousal-seeking indicators, which are very active behaviors, which might include things like restlessness, sensation-seeking, escape-related behavior, unprovoked aggression, all sorts of things to try and make something different happen. But because this doesn't work and the animal isn't managing to really raise its arousal levels effectively, you also get indications of it not working. So those drowsy behaviors start to come in, such as lying awake and yawning. So in a series of experiments, we've compared various rather monotonous treatments, which we thought might be the boring ones, compared with more stimulating conditions. So we compared varied versus monotonous tasks in rats, and then we moved on to laboratory ferrets, where we looked at the presence or absence of exploratory playtime in the ferrets, where they were allowed to explore the room outside their cage with various enrichment items. We compared novel and complex environmental enrichment versus their standard home cage enrichment. And we've recently compared the presence or absence of positive reinforcement training. And much of this work was done with Alice Dancer, who was a PhD student on the project. And this photo of her here, if I can, well, the photo of the one with the hat is her graduating yesterday from her PhD. And Maria Diaz-Leon and Jenny Bisley were co-supervisors of Alice. So to compare the effects of these treatments, we used two sorts of approaches. So we used sensation-seeking tests, which were adapted from Mahar and Mason, which was published in 2012. And we also used a suboptimal arousal framework to help us interpret their spontaneous behavior. And I'll explain both in turn. So here are some examples of the sensation-seeking tests. So in this idea, you present the animals with stimuli ranging between negative and positive. And the hypothesis is that if they're bored, they'll not only want to come and investigate the positive ones and spend a long time investigating them, but they'll also want to investigate the negative ones too, just to have some different sensation from what they're experiencing in their boring lives. So I must learn to use this pointer. Hang on a second. Let me just see if I can. No. Okay, let's see. Yes, okay. So here we have a ferret grimacing because it's sniffing some peppermint oil in this tea strainer, and they really don't like this. They shake their heads, and if they've got interesting things to do, they won't investigate it. these ferrets are looking at a flashing bike light. Here are the neutral stimuli, which are basically empty containers. This ferret is investigating a ball with a bell, which they really love playing with. And this ferret is licking at a tea strainer that's got some salmon oil in it. So sensation-seeking tests have yielded very interesting results so far. So in a series of 3 experiments with mink, which are closely related to ferrets, the Mason lab have found that mink without environmental enrichment contacted ambiguous stimuli, and sometimes, depending on the study, negative and positive stimuli more than those that had environmental enrichment. We also found with our lab ferrets who had not had the playtime outside their cage on the previous day, the next day they contacted negative and neutral stimuli more than those who had playtime. We're also currently testing it with the positive reinforcement training, so watch that space. So moving on to the suboptimal arousal framework, this allows us to look at the low arousal manifestations of boredom as well, not just the arousal seeking ones. And that's important because although the sensation seeking test is really showing a lot of promise and revealing just how much animals want stimulation when they don't have it, there are other states than boredom that could increase sort of sensation seeking, such as optimism, for example. Whereas boredom is quite unique in having these 2 sort of polar opposite manifestations. And having this framework means that when we're looking at their spontaneous behavior, we can develop really sort of hypothesis-driven predictions about which behaviors should increase or decrease if the animals are bored. So looking at a selection of arousal-seeking behaviors first, we looked at escape-related behavior. So here we have the rat doing its task. It's just finished one of the trials, and it's showing some spontaneous escape behavior, which is trying to jump out of the box. And also we trained the rats that if they stood on this platform, the exit platform, then we would lift them out of the arena. In the ferrets, this ferret is demonstrating a mixture of cage biting and scrabbling behavior. Now, in mink, scrabbling seems to be social stress related in that it's directed at the neighboring mink, and mink are solitary animals, whereas we think this is escape behavior in ferrets because they're social animals and the behavior seems to be directed at the exit rather than at the neighboring ferret. So as well as that, we looked at self-directed behavior such as grooming, and this can be sort of to increase the level of stimulation. If the grooming is excessive. Also excessive eating or drinking. So these ferrets here, the water spout is annoyingly just off the side of the screen, but these 2 ferrets you can see are just pushing each other and shoving each other out of the way as they drink. The video is really long, and they did this for a while, then they went off and they came back and drank more. So if they're doing that more in monotonous environments than in stimulated one, then it could be a case of polydipsia. And we also looked at aggression levels as well. People pick fights more when they're bored, for example. Turning to the suboptimal low arousal behaviors, we looked at yawning and lying awake, which these 2 ferrets are demonstrating. Room focus, which was the ferrets basically looking out into the room environment. And sleeping during the active period. So ferrets are active in the morning and the evening, and if they're sleeping then maybe that's an indication that they're not having enough stimulation to keep them awake. So the results using this sort of idea are varied. So in the mink studies, they didn't use the framework quite the way that we have, but they have found lying awake to increase, not decrease, with environmental enrichment. And it also showed no relationship with sensation-seeking behavior or with stereotypic behavior. So they've concluded that perhaps it's not a great indicator of boredom, or perhaps the mink weren't actually bored they were sensation seeking for another reason. We've had a bit more luck with it. So with the lab ferrets who had not had playtime on the previous day, they screeched aggressively and they lay awake more than those who had had playtime. Also, the ferrets in the standard conditions scrabbled more and they showed more suboptimal arousal behavior than when they had novel environmental enrichment. And also, they lay awake and groomed and stretched more when they had than when they had complex environmental enrichment. So in both sets of experiments, we have got that mixture of both those kind of sensation-seeking, arousal-seeking behaviors and the low arousal behaviors occurring together. With the rats, we did find that in the monotonous task, they showed more of that exit-related behavior, so standing on the platform, than those on the varied task. But although we looked for signs of suboptimal arousal, we didn't see anything to do with that. So yeah, we can't really conclude that the rats were bored in the monotonous task. We've started to look at what behavior replaces the boredom behavior. Now, of course, if you give environmental enrichment to the animals, they interact with it. And that is very important from an applied sense. You'd hope that you've given them something that they do want to, well, you've given them something to do, right? So that should help them not be bored. So it's a relevant result, but it's not directly comparable with what they do when they're bored, because of course, in the boring situation, they don't have environmental enrichment to interact with. So that's a whole set of behavior that's not even possible. So when we take all the time that they were interacting with environmental enrichment out of the equation, and you look at what they're doing when they're not interacting with it, then that becomes quite interesting too. And we found that in some of our treatments, the stimulation increased explorative behavior generally. So the ferrets were looking outside the cage more, they were sniffing around in their bedding more. So it seems that they have entered a kind of more wakeful exploratory state more generally. We've also found that the complex enrichment increased social play once the environmental enrichment was no longer novel. Just letting you enjoy that for a moment. So sweet. So this is really good. These are all relatively positive and high arousal behaviors, which you'd kind of expect if you've given them stimulation and you're wanting them to have fun rather than being bored, then this is a really good sign. But it's not the only thing we found. We found that when the ferrets had had playtime the previous day, they increased the amount that they slept the next day, even though the amount of time lying awake was reduced. Also, once it was no longer novel, some of the environmental enrichments increased sleeping again. So this bed was obviously a comfy place to sleep in, even though this ferret has decided to sleep in a particularly uncomfortable posture. And in another study by Abu Ishmael and Mendel, not looking at boredom, but welfare more specifically, rats with complex environmental enrichment also had improved sleep. So this got me thinking about the relationship between boredom and tiredness. So obviously they share some of those sort of drowsy behaviors and other indicators. But unlike boredom, tiredness causes sort of sensation avoidance rather than sensation seeking behavior. So I've talked a bit about how boredom causes drowsiness, and in English, another word for boredom is tiresomeness. So you can describe something as tiresome. But it also made me think about the relationship the other way as well. And in 2001, there was a study that showed that this can happen in humans as well. So students who had had not enough sleep were more likely to report lectures as boring. So sorry for those of you who are sleep deprived today. But maybe this is happening with animals as well, where if we don't give them good opportunities for high quality sleep, they are unable to engage with what enrichment we do give, and they're more prone to boredom. So boredom is this kind of limbo between sleep and wakefulness. And maybe to have good welfare, animals really need the opportunity to be able to transition fully and freely between wakefulness and sleep. So they do need meaningful and engaging things to do when they're awake, but also comfort and safety when they're sleeping. So taken together, I think this is a bit of a reminder that feelings such as boredom aren't experienced in isolation from all the others. So in studying boredom, we've kind of had insights into tiredness as well and the importance of sleep quality. So going back to that statement I made on the first slide, chronic inescapable boredom is a risk unless we can provide sufficient stimulation. And I think that this set of studies has demonstrated that. But I'd also add that this is provided we've also given the animals the opportunity to have high quality sleep. And only that way can we solve that limbo between sleep and stimulation. Thanks for listening.
Thank you very much, Charlie. If there are any questions for Charlie, please raise your hand. And can I remind the online audience that if you want to ask questions, please type in your questions now and Hugh will read them out. Thank you.
Hi, I'm Jo Edgar from University of Bristol. Thank you for a really great talk. I was just wondering what your thoughts are on distinguishing boredom-related behaviours from stereotypies. I'm just thinking about the kind of scrabbling example you put and whether it's perhaps an indicator of boredom or maybe like a hangover from a previous environment.
Yeah, so yeah, it's interesting. I think you know, lay people, when they see stereotypic behavior, they'll often go to boredom as their kind of go-to explanation. But research shows that actually stereotypic behavior often has much more specific motivations to do with frustration of something in particular. I do think sometimes boredom can increase the rate of maybe some stereotypies, but not others. Escape-related ones are kind of an obvious set of motivations to go to, because people and animals in boring situations do try and escape that situation, but you wouldn't necessarily expect sort of dietary motivated stereotypies to increase in boredom, for example. But it's a new area of research, so it'd be interesting to know which behaviors, which stereotypies are or are not affected by boredom. Yeah.
We have time for 2 more questions. Mike first and there second.
Thanks, Charlie, for a great talk. I'm just wondering if you have any idea about how important physical and mental stimulation are in decreasing boredom, and whether if you have a lot of one, you don't need so much of the other, or whether you probably need both.
Yeah, so by using a number of different paradigms, that is something that we've been sort of trying to separate out, and I don't yet have an answer. But it was one of the ideas between the varied and the monotonous task, because the activities that the rats had to do were completely identical between the 2 tasks. And it was only the sort of sensory aspects of the task that varied or were completely stable. But yeah, with the physical enrichments and the playtime, you've obviously got exercise thrown into it. And I do think both aspects are probably really important to animals. And maybe, you know, people talk about sort of boredom as a state of not having anything to do, or as wanting to experience something different. So it does suggest both those components are important. Yeah, thanks for asking.
Short question and short answers. Thank you.
Yeah. Thank you. I'm Ayola from Nigeria, and I want to confirm if you consider singleness and with companionship in your research as it affects boredom.
Sorry, can you take the microphone a little further from your mouth, because like it was making noise.
Oh, sorry. I'm saying, do you consider singleness and companionship boredom?
Yes, I do think that, yeah, social contact is probably very important for some animals. You know, a lot of this work has been done on mink, which are solitary by nature once they're adults. So it will be important for some animals, but not others. I do think for social animals, they have that kind of advantage of if they have another individual in their life, it can really break the monotony because there's someone else to help each day be different. Whereas if they're just interacting with a static environment, it's much harder and maybe they'd be more prone to boredom. I hope that answered your question. Thanks.
Thank you, Charlie. Our next speaker is Peter Sandøe, who is going to tell us something about what we owe feral animals.
Thank you. Yeah, I'm trained as a philosopher, and I think I'm a jack of all trades and master of none. But I have one quality that I'm very proud of. I'm able to attract really smart people to work with me. Here I have two eminent animal welfare scientists, Janne Winther Christensen from Aarhus University, Alistair Lawrence from Edinburgh, and two smart environmental ethicists, Christian Gamba and Claire Palmer, whom you already met yesterday. So with their help, I will get there. And I'm going to complicate your world. Yesterday, with Claire's talk, you got the feeling, oh, they're both wild and domestic animals. And now I'm going to bring in a third category of animals, guys, feral animals. We like to put things in boxes. This is something that we sometimes give things like this we may give to our children. Okay, guys, there are two kinds of animals there. There are those on the farm and the wild ones, and then you have the whole animal universe. And that's often how we see things. We draw this sharp distinction between the domestic animals, which, I mean, originally there were only wild. 45,000 years ago, there were only wild animals. Then came early domestication. We don't know exactly when the dog was domesticated, but somewhere between 45,000 years or 10,000 years ago, we started having the first domestic animals. The domestic animals are animals that have been used by humans, been tamed, and have been selected. So the definition of domestication is there's a combination of tameness and genetic selection, whereas wild animals have evolved naturally and lived independently of us. And with that, then we have a simple moral universe until Claire complicated things yesterday. We had this nice thing that we have separate duties to these kinds of animals. To the domestic animals, we have a duty of care, provide food and veterinary care. It's also enshrined in legislation that as soon as you have domestic animals, then you have this duty of care. Whereas in most legislations, wild animals, we don't have a similar obligation. They should be left to live their own lives, and their welfare is not our responsibility. And if that jaguar does some horrible things to that other animal, well, that's their problem. It's not our business. And every day, if we just look out in our garden, most of it we don't see, but if you look carefully, that's happening all the time. And okay, that's their problem. It's not our problem. So that's sort of the neat way of dividing up our universe. However, we know that that's too simple, because if we have two distinctions, we can make 4 groups of animals. You probably already have been to a lot of the group 3. That's the wild animals, the zoo and hobby animals, that you take a wild animals and bring it to a wrong place, to a zoo, sorry, zoo people. Bring it to a zoo, or you bring it into a private home in a terrarium or something like that. And we have a huge discussion about that. Not at this conference, but many animal welfare conferences have been discussions about zoo animals. But I'm focusing now on a group of animals that I think so far has not been discussed very much. These are feral animals. These are animals that used to be domesticated animals, but then went on and lived their own lives. Prominent examples are Mustangs in the Western US. If you follow anything with US politics, you know that the one gang wants to shoot them and the other gang wants to leave them alone. So you have a huge polarized debate in the United States about the Mustangs. Less contentious, but still controversial thing is other free-living camels in Australia. They live in an area where there are no humans, but some conservationists think they don't belong there, so they go in choppers and shoot them. So there's also a debate about, well, what should we do about the camels in Australia? So we have these animals that used to be domestic animals, but then left and lived their own life. And these are the focus of the current presentation. So, and the question, of course, comes, what do we owe these animals? They are domestic in origin, but largely live largely independently of people. Do we have a duty of care, or should we let them be? And I'm going to talk about 2 cases where there have been disagreements and controversies. So these are 2 examples from both sides of the pond. The most western part you can get in Europe, western end of Scotland, and the most eastern part you can get of North America, eastern part of Canada. And these are cases, I should say from the start, where people are doing research. Researchers, we talked a bit nervous about this. Now you're going to expose us in a negative way. But I should say that the fact that the research is done is part of the background that we can do this presentation. So, start with the horses of Sable Island. Sable Island is a little bit of sand, 660 kilometers east of Nova Scotia. So it's a sort of strip of sand out in the Atlantic Ocean, maybe the last bit before you say, well, now you've left North America. And many years ago, people had the problem when they were sailing around, they could run out of foodstuff. So they've got the idea about putting animals on islands. So actually sailors back in the 18th century deposited a number of farm animals out there, and some of them have survived up to this day. So for 300 years, there have been horses on that. So these horses were actually left by sailors 300 years ago, and a population of horses have lived on this island ever since. So, and the herd has increased, and there were about 300-400 in the 1970s. Today, there are around 600 of them. You may have seen them on coffee table books and pictures. They're quite pretty. But they also live a harsh life. Average winter mortality rate is about 12%, so about 70 horses die every winter, and some winters is pretty tough. In the winter of 2023, 25% of them died. And they live rather short lives. I think it's about 4 years. I mean, you know, a normal horse at a field will live about 25 years or more. These horses on average live about 4 years. So, and that's even shorter than most sort of feral horses in other places. The Mustangs, I think, live around 11 years. So they have a pretty tough life, but they are not managed in any way. No feeding, no veterinary care, and also no culling. And no duty of care is accepted. The Canadian authorities said they must be treated as a naturalized population. But such cute horses, of course, gives rise to controversy. There's no management policy, gives rise to controversy for 2 quarters, both from the side of the conservation biologists and from the side of the welfare people. Welfare people, they care about poor horse welfare. In one document, we found abandoned animals under stress. Janne said that's a slight understatement. They probably undergo very severe suffering. Not only do they die from starvation, but a lot of them die from what's called sand colic, and that's supposed to be the most nasty way you can die as a horse. So yeah, not nice. On the other hand, the conservation biologists will say, well, they're non-native species. You may even call them an invasive species, and they're destroying the island's unique biodiversity because they're actually sort of interfering with what's happening there. So now there's a controversy whether to remove the horses to protect the ecosystem or to manage the horse population for welfare or ecological reasons, continue to treat them as a wild population. But of course, that depends on values. And as you know, science may inform value issues, but value issues are separate issues. That's why some of us philosophers are led up here. The other case is from the most western part you can get of Scotland. So you have the Outer Hebrides, and then you just go another 100 kilometers to the west, and you have some very small islands out there. And the 2 islands we are talking about is the island of Sandøe and the island of Herta. Sandøe, there's been a population of sheep out there for 2,000 to 3,000 years. And we don't know exactly, but 2,000 to 3,000 years. Some early Bronze Age humans brought them there, and then the humans left, and they've been there. Herta used to be inhabited by people, but in 1930, they gave up. So in 1930, the last people were shipped off. So now Herta, there's no one living there, took all the animals off, and then they moved some sheep from Sandøe to Herta. And the sheep I'm going to talk about now live on Herta, but they're part of the Sandøe population that were moved in 1930 to the island Herta. And that has given rise to a very prominent controversy that's been covered by, among others, the BBC. As I said, they originate from this Bronze Age population of sheep. They were introduced in 1930. At regular intervals, many sheep, like the sable horses, die of starvation, much larger. Some years they're about 2,000, next year there'll be 1,000. So sometimes the population can be halved in a tough winter. And starvation clearly causes severe suffering, there's no doubt. I mean, that dying from starvation is not a nice death. And until recently, this has not been an issue, but recently the suffering has become controversial because there are two vets who work in the western end of Scotland who make a petition to the Scottish government and the National Trust for Scotland. So the Scottish government is legally responsible. National Trust is an organization that manages these islands. And they said that the number of animals outstrayed available grazing. You can see here's a concept coming out of the research project. You can see 1 year, there's nearly 2,000. Next year, they're about only less than 1,000. So there's dramatic drops and changes in population. So the main issue, both sides of this debate seem to agree on the premise outlined earlier. For domestic animals, there's a duty of care. For wild animals, there's no such duty. So the issue seems to be about how to classify the sheep. Are they domestic and wild? I should say that it's both a legal and an ethical debate. The legal debate is extremely complicated. I'm not going to bore you with that, but just say there's also, of course, also a legal side. And British law, I never understood why did you leave the EU? I mean, you had some complicated laws, but okay. Sorry about that. Anyway, I'm only going to talk about the moral side, and then you just know there's, of course, the legal side to it too. National Trust for Scotland said the animals were related to ancient wild sheep and were treated as feral, so there's presumption against intervention. The Scottish government said St Kilda sheep were similar to wild deer, and they were unowned and unmanaged. That's important for the law. Unowned, unmanaged means that there's no duty of care. But these vets say, no, they've been handled by humans until 1930, which is debated, as you say. The scientists we work with disagree, so there's a big discussion about whether they were actually managed or just sometimes used. So the two vets describe them as sheep, as domestic animals, they're left to live in a wild state, which is not nice. Complications about both cases is that they're actually also part of a research effort. The St Kilda soy sheep are not just living independent lives. They're also object of a longitudinal research effort going back to the 1980s in the field of population biology. So population biologists love this because you have a natural selection process, as it's rather extreme, allows you to do really interesting population genetic studies. The sable horses are also subjects of extensive monitoring, not going that far back. So even though they are not managed, they are constantly monitored. But it's still argued by those who make policy for both groups that they're essentially wild population. And I think they have a case. I mean, the fact that a population of elephants in Africa is being monitored doesn't make them domestic animals. So if you can follow my argument, that will be the argument of the researchers, that the fact that we monitor them doesn't turn them into domestic animals. There's also a potential controversy here regarding means of population control. In the case of the sheep, the two vets raising the case seem to be arguing in favor of population control, but they're leaving it open whether it should be lethal. That would be a big, practical issue, how are you actually going to manage the population? In the case of the Sable Island horses, on the other hand, there's strong public opposition to lethal population control. As soon as you come to horses, don't shoot horses, then you get in trouble. It's okay to shoot other animals, but don't shoot horses. So we draw these distinctions. It's okay to shoot deer, but not to shoot horses. And as you heard in Claire Palmer's talk the first day, well, even for wild animals, things are no longer that simple. And in reality, of course, humans manage wild animals very differently. If you come to deer, in my own country, Denmark, deer is being managed. They're being managed by hunting, and it will be seen as cruel not to do this management with the consequence that you will have big starvation. We have a few wolves in one end of Denmark, but otherwise we'd have no predators. And as you heard also from Claire, there are new ethical arguments focused on preventing or alleviating wild animal sufferings. One is that as soon as we have a role, and now with climate change and all the other things we do, it's very difficult to argue that anything is happening independently of us. And then you have people like Oscar Horta and others on the philosophical side who argue that we should relieve suffering as far as we can. So we actually have a positive duty to relieve suffering of wild animals. Okay, that brings me to the concluding thoughts. Feral animals challenge deep-rooted distinctions between wild and domestic animals. So that could be a case that can help us to rethink our moral obligation to these animals. In the view, and I share the view of Claire Palmer from the first day, that being a pluralist, I think actually I'm not the kind of guy who say, oh, it's only animal welfare or it's only conservation. I can see both sides, and I can see that you can have a meaningful discussion about how to balance these things. Preventing animal suffering, I'm actually in favor of doing that if you can do it with no other big cost to other things. Taking animal lives, I'm from Denmark, so I'm a killing bastard, so I don't mind that too much, but I know there are sensitivities across the globe on these things. Enabling research, I'm a scientist. I'm a great fan of research. I think it's weird not to believe in the value of that. Human involvement, the more we involve, the more we kind of get an obligation. We should care about biodiversity and ecosystem function. We should care about wildness and naturalness. So there's so many things at play here, and there will be no simple answer, but there will be a need to work on these issues. And last thing, should just acknowledge two very nice people who are involved in the actual sheep stuff, got us into this. We decided there shouldn't be co-authors because that will be too much of a conflict of interest, but we should also acknowledge that we have got a lot of good advice from them, Dan Nossi and Josephine Pemberton. Thank you very much.
Thank you very much, Peter, for a fascinating talk. Question there, yes, please.
Thanks, Peter. Juan Darras, Book PR Brazil. Thanks for your talk. That's amazing. Just wondering if you consider to frame this with feral dogs and cats and pigeons that live among us, like in cities and things like that, because they're closer to us. So I think that will be much more complicated to discuss these matters than with the same framework. Thank you.
I have to reveal something about, apart from being a philosopher, I'm also a crazy cat researcher. So I've been doing a lot of research on feral cats. I actually happen to think that we should actually kind of let them live their lives within certain bounds. Feral dogs is an interesting issue. When you come from the West, you have this idea, oh, they all need to be neutered. Last year, I was at a conference twice with one from India doing studies in Kolkata on dogs. And I asked, why not neuter? No, that's not natural. So you could even start thinking of these dogs having their own life, having their own autonomy. I agree that it's going to be controversial in the West where we sort of next to horses, dogs and cats, my God, don't do that. But I think there's another perspective there. So I think if we also want to be not too imperialistic, but actually allow a sort of global South perspective, dogs and cats could be a really interesting case for discussion here.
Joe.
So Joe Garner, Stanford. Thank you. It was very thought-provoking. So as you were talking, I was really struck by a guy called Ed Price. So Ed Price, unfortunately, has passed away now, but was really the leading theorist on domestication as a process. And central to his thinking was the idea that domestication was the combination of sort of Tinbergian phylogeny, so long-term changes in the animal, particularly neoteny, combined with things that are learned by the animal, which we might, for instance, call tameness, that are learned every generation. And so the domesticated animal is a combination of an animal that we have changed genetically in a very fundamental way, and the combination of learned changes. And from that perspective, it would strike me that feral animals are maybe animals with that genetic change, but without the learned behavioral differences. And so in that case, if we call an animal feral, by definition, have we not changed it, even if that change occurred thousands of years ago? And if that's the case, then do we have a duty of care, even though the change to that animal was made thousands of years ago before anybody was doing philosophy? So I just wondered if you had thoughts on that.
Yeah, I do have thoughts.
Helps.
And I do think that there are actually the sort of genetic changes done to the animals vary dramatically. On the one end, you have the dog. I think the dog is not a wolf in many ways. It's the only animal I know that actually would be more sad by losing a human, like losing a conspecific. On the other hand, you have animals like cats and horses. I mean, they don't give a damn about us. They use us for various purposes. And they very easily go feral and have no problem at all finding their way. The problem is that people think they need them. But I did cat studies and feral cats, and they were all well fed. They're pretty smart animals. So I think this idea that there's just one way we change them. No, some are changed dramatically. Others changes are not really mattering to what we're discussing about. So I think we should take it case by case rather than thinking of domestication as a one thing.
Thank you very much, Peter. Our next speaker is Claire Witham. We are changing species again, and Claire will talk to us about refining the monitoring of weight in laboratory species.
Hi, so I'm mainly going to talk about macaques today. The mice are a few slides at the end, so it's mostly going to be a monkey-focused talk. So I work with laboratory macaques. I'm just going to go quickly, lightly, one of the problems we've been having with using weight as a measure and our solution to that problem, and then talk about some of the methods we're using. So the problem is weight loss is quite often used as a key metric, especially in animal experimentations. One of these usually part of a humane endpoint in an experiment. And you might have a defined limit of 10% weight loss, 20% weight loss being considered a humane endpoint. The weight loss by itself is useful. Yeah, an animal losing weight, that's bad. But it can be very misleading in growing animals. So if you, especially if you've got a long-term experiment and you've got an animal, so for example, a macaque, they might start on research at 18 months old. Macaques can keep growing to they're 8 years old. So throughout that experiment, they should be growing. If we're just looking at weight loss alone, we're failing to capture a failure to grow, which can be quite serious. It can be very serious. So the lack of growth can be a serious problem, and it's just not picked up by that weight loss metric. So we started looking and come up with a few discussions with the senior staff at the centre. And it was mentioned in humans with babies, they use growth curves. And this is on the left is an example from the Centre for Disease Control in the US. This is kind of standard growth chart used there. There's two different lines there. The bottom set of lines are the lines for weight. The top set is the lines for length. And as your child's born, you get the weight, you chart the progress, and you're kind of expecting that the child starts on the 50th percentile of that line, so the middle curve. They kind of follow that trajectory, so they keep growing. And we started looking to see how easy this was to do with, so first with macaques. And we've looked at the methods that the CDC were using in America, and they're using these models called lambda, mu, sigma. You can't just simply fit a curve to the weights. The weights are not normally distributed at different across the ages, and they're skewed, and this level of skewness varies with age. This particular model allows you to fit percentile curves accounting for this skew. And there's our product package called Gamless that allows this to be fitted to custom data sets. And quite usefully, you only need actually two measures. You just need your age and your weight. And there's a few different variants of the model, but the package automatically fits one of the best, minimizes the information criterion. So we started looking at this starting to use these macaques. We've got, so I work at the Centre for Macaques. We've got currently about 174 macaques, but it varies throughout the years. The centre was established in 2003. We've got good weight records from 2008 that we've been using in this study. The animals are housed in a mixture of breeding groups and stock groups, and between 2 and 26 animals, usually between 2 and 15 animals is kind of norm. They're housed indoors in these enclosures, and they're fed a complete primate diet with some foraging intervals. So we've got a database, we've got all the weights on the database, and we took these to look at putting into the model. We've got, say, 830 data from 830 macaques. We've excluded any macaques that we knew had a serious health problem, like a known gastrointestinal issue. We excluded any females that are pregnant or lactating. And that left us with just about 8,000 weights from the animals. They're weighed on a regular basis for husbandry and veterinary procedures, purposes. This is either done awake, if they're stated for another purpose, they get weighed. If they're awake, we've got a set of scales that attaches to their cage, and they come in those to be weighed. Weights are recorded onto a paper health record, and that's then transferred to a centralized database. So we use this and we calculate our growth curves. Now, I should say, we have a lot more monkeys under the age of 5 than we do older monkeys. Most of our monkeys are supplied at academic universities between the age of 3 and 5. So you'll see from these that the growth curves, male and female monkeys are very sexually dimorphic. So we've got different status sets for female and males. Up to 5, we've got quite smooth curves. After that gets a little bit wobbly as we get a little less data, and we've cut it off at 15 years for female and 10 years for males, just from complete lack of data. Well, not complete lack, but less data above those ages. You see, we've got the different percentile curves here. So we're starting 5%, 10%, 25%, 50%, 75%, 95%. And yes, females and males. And particularly with the growing, we're interested, you can grow up to 8 years. You see the females and males slightly different. The females tend to increase at a fairly similar weight and then flatten out. The males have 2 phases, so they grow, so slow down, and then testosterone hits in adolescence, and we get another growth spurt and then flatten out. From the way we're using these is we can plot, this is a family of 5 siblings. They've all got the same dad. They're all born in 2017. So we've got 5 siblings that kind of cover the whole range here. We've got, say, the female or male plotted on the appropriate curves. And we've got, say, ones at the bottom really didn't do too well. We've got a monkey that actually stopped growing. She didn't really lose much weight. There's the odd kind of up and down in the weights, but she generally lost maintained a fairly stable rate, but actually she stopped growing when she was 3 years old and quickly fell away from the growth curves. I've got various arrows on here indicating some of the events that happen in the monkeys' lives. So when they're between about 18 months and 3 years, they're removed from the natal group and set up in the stock group. You do get the odd fight injuries. And with the males, they went into a stock group with an older male, and the removal of that older male from that stock group was an event. At the opposite end, we've got Castor, who was the son of the alpha female. She was quite big, and this is Castor when he was 6 years old. He did end up being very big, but you see, when he was weaned, so moved from the stock group, his weight did dip a bit. The older male was then removed from his group, and his weight shot off and ended up well above 95%. The others are kind of in between. Calypso is kind of the kind of expected curve where they pretty much stay on. Minor few variations, but generally stay on the growth curve. Coffee had a serious facial injury, which affected his ability to eat. You can see with a dip there caused by that. And Cinnamon was fairly straightforward, just the odd up and down. And occasionally you do get errors in weighing, which is occasionally you get the odd peak, which might just be an error. This is one group of family. So males and females have different curves, but we can directly compare male to female if we use on the same chart if we use Z scores. So if you have a percentile measure, you can quite easily convert it into Z scores. You can treat these as normally distributed data. It does allow useful in analysis. And be able to have got a male here and 2 females plotted on the same curve. You can see Calypso is fairly stable, Keonia drops off, Castor drops a bit and then goes high. And there's a practical implication. We've now got a version of this in our database. It's a little bit basic at the moment due to the lack of plotting skills in the actual database, but for any animal in the colony, you can click on and get a growth curve. And this is another monkey that's disappeared off the top. Once a month, our vet gets scores from about a quarter, but weights for about a quarter of the colony, and he in detail at the growth curves for any animals that might be struggling. And we're just starting to look at how we might analyze this data in other ways. So I'm just going to go for one suggestion, which is that I do a lot of work around early life experience in the centre. We've got a lot of measures on things like maternal rank, maternal weight, age, previous offspring, and also various measures of maternal behaviour, which is how warm they are towards the infant, how protective they are, how rejective. So we've got all this data and we start looking at how we can combine this with the models to really look at what the impact on some of the growth curves might be. And switch gears completely. So the Centre for Macaques is run by the Medical Research Council as part of the Harwell Institute. Another part of the Harwell Institute is the Mary Lyon Centre, which is a mouse genetics facility, it's the national facility. Big difference in scale and plans, but they do have a lot of data on mice, particularly the wild type mice. And we've just started looking at fitting growth curves to this mouse data set. We've got some data that we've had a summer student fit these curves to. It's just ignore the black line for now, it's just an example from one each, but you can see you don't get data very early on. These are switched from years to weeks now, but you've got the week from 2 weeks onwards, you've got the growth curve for males and females. The way we're looking at using this in mice is slightly different because we're more interested in procedures. This is not real data now, this is simulated. So what we're suggesting is we can start looking at effective procedures, especially procedures, phenotype and type procedures that happen in early life. And we just wanted to highlight this. This is the kind of idea that you might have a mouse that's still growing. And so the procedure user, in this case, we use the first 3 weeks to get the body weight percentile, and then they've had a procedure, a simulated procedure, and that procedure's caused them to stop growing. The weight actually stop growing as quickly. The weight's continuing to increase onto the left column. The expected weight's much higher, but you don't see an effect on the actual weight loss until the final week. There's just a way that might, how we could use these with procedures. So the conclusion's a little bit ahead of time, so I'll slow down a minute. So I think percentile growth curves are quite really useful tool, especially when you're looking at growing animals. They're really quite easy to implement. You do need a basic knowledge of R, but it's fairly straightforward to pick up. You can create them for different sets of animals. So especially for sexual dimorphic animals, you need male and female. For mice, you need different strains. And they can be used to reveal subtle effects of illnesses, injuries, sexual disturbances, etc. And can pick up on things earlier than weight loss would do. This caveat, you do need quite a bit of data to create these curves. And so for smaller population, like smaller in zoos, you have a small population of animals, you're unlikely to have enough data to do that. But there are ways to combine with the same species across zoos or so to get that data. So with that, I'll just say thank you to my various colleagues at Centre for Macaques and Mary Lyon Centre. And thank you for listening if you've got any questions.
Thank you very much, Claire. We have a question down here, front.
Thank you very much for a really great talk. I'm just thinking back to Charlie's talk earlier and about how there are lots of different things that can happen if you're in maybe a more negative affective state. So if you're bored, you might start eating more, you might be sleeping more. And in those cases, you might be actually gaining more weight, or maybe you're just following your growth curve because there are other things going on at the same time. So I'm wondering, is that a potential limitation, how you think we might deal with that practically if we're using these growth curves?
Yeah, there's a lot of different factors of play here, especially with gaining weight. In that case, the monkey became the dominant one in the group, so he had first pick of the food. Whereas before he was so especially monkeys got a huge thing about social rank as well. I think it just gives you that thing to go and actually look at that first. We've got CCTV cameras, we can go back and look at the behaviour from the last year. So if we do see a weight change, we can then track back and see, okay, this monkey's flying off the top, what's he doing, what's she doing? Sometimes with females, it's just that they've got pregnant. So, so we've got quite a lot of breeding females. So yeah, it's just giving you that key, and then you especially it's not so much the ones that gain a lot of weight, but the ones that stop growing. They're the ones we start coming up at our regular senior staff meetings. What's going on with this animal? Do we need to do anything? What is the future?
That's great. Thank you very much.
Vicky, can you pass it to Anna? Thank you.
Thank you very much. This was very interesting. I may have missed this, but is this new data that that you are collecting to generate this growth curve, or is this exploiting what you already?
The monkey one is exploiting what was in the colony since 2000, like records since 2008. We are generating more regular weights now. So up until about 2021, it was fairly sporadic weighing. Now they're weighed every 4 months, so we have a bit more of a regular weights, and they'll be included in future. The mouse started off with getting data from an international database, and then because there's not that many weights for young mice, they did a specific study on weighing the mice every week between 2 weeks and 10 weeks at Harwell.
Okay, thank you. So congratulations to this. As someone who works across species and applications, it strikes me as we are decades behind in lab animal management as regards precision and as regards making use of the data we collected. It's very important. Thank you.
I'll use the chairperson's prerogative and ask a question. So this, you started off by saying we normally have as a humane endpoint for our treatments when we do experiments, 20% weight loss or 25% weight loss. And we should look more at the trajectory to be able to know when it's a good time. So the provocative question is, so this is used in research, but you can have animals that you are treating, your dog is being treated for something and it does lose 25% of its weight, but we are not putting that dog now. So how is that?
So we have, most of our monkeys aren't on procedure because they're breeding animals. So we do get big weight losses. And they're usually treated by the vet, and it becomes a discussion of whether you can treat or not. Most project licenses for research have that built in, and it's part of the project license in the UK as the Home Office that say set those conditions, or make sure you set those conditions. I think very much you start from, you see a big weight loss. First of all, it has, with our lot, usually is a female that's been pregnant, and is that weight loss expected? Some weight loss expected. Is a very big animal, and he's actually got a bit more active for a reason. We've got a big male, our biggest male regularly loses weight during breeding season. He gets more active, and someone might come back to the boredom question. It's not necessarily a yes, we have to kill now, but it's just a feature of most project licenses is that will be built in somewhere. Thank you.
If nothing else, I have another question. Oh no, here's one. Do that.
Thank you, really enjoyed that. We have a real issue in that our animals, because we have a lot of captive wild animals, fluctuate in the year. And if they're under a Home Office license, it is a nightmare. Badgers, particularly, they put on a huge amount of weight and then lose a lot of weight. Do you think we could use your model for modeling that?
I think it would give you that thing of, so if you've got, we do get seasonal fluctuations, especially with mating season as well. And I think what it gives you is a way of getting a normalized Z score out. So if the animal's growing, you can take that into account. And rather than just look at weight loss, you can get these Z scores out, which you compare, at that point, you can compare age 1 to age 2, 8 to age 3. And then you can get some idea of what is the normal seasonal fluctuation and say, okay, we say, okay, a male would usually maybe lose half a Z score. Once it gets beyond half a Z score, then it becomes a veterinary matter. So that's how you could.
Oh, that's really interesting. That's really helpful. Thank you.
Thank you very much, Claire. Our next speaker today is a local. It is Anna Olsson, and she will talk to us about open science for animal welfare and applied ethology.
Okay, good. Good morning, everyone. I do not recommend giving a long talk at a conference where you are also a local organizer, but here we are. The good thing is I have given this talk before in previous versions, and I have great collaborators. This is based on an ongoing collaboration. It started with myself and Christian Navrut in 2020 towards 2021, and we prepared a workshop for the ISAC Congress in 2021. And the data that I will present here comes from the questionnaire that we did to the Congress participants. A little later, Helen Gray from Newcastle also came in and has collaborated with us. And more recently this year, we are expanding this in a collaboration that involves people from the Cost Action Tea Time, which is about home cage monitoring in mice. So what is open science? I'd like to highlight this paper co-authored with Birte, among others, published in PNAS Nexus, and you see the figure here. Open science is about accessibility, reproducibility, transparency. These are the motivations, the drivers, what you could wish to achieve with the open science. It is achieved through a number of measures, sharing data, using preprints, using publications, open access publishing, using repository, pre-registration, registered reports, and open peer review. I will not try to cover all this in 15 minutes, so I will focus on sharing, pre-printing, pre-registrations, and well, just a very tiny bit about open data. And starting with preprints. Preprints is a complete manuscript shared with a public audience without peer review. I think the majority of you are probably familiar with this and have used them in some way. BioRxiv is probably the place, the preprint server that most of us would turn to. The OSF also has a preprint section. There are other specialized, this is general, there are other specialized preprint servers such as medRxiv, less relevant for us. This was the first one that turned up when I searched for animal welfare on BioRxiv this morning, and it happens to be a 2024 one. I don't think anyone in the room is the co-author, but there are several familiar names to me and probably to many of you as well. So animal welfare researchers do use BioRxiv for their publications. When we asked the participants to the 2021 online conference, we had about a 30% response rate. So this is over 100 respondents out of just over 300 Congress participants. And you can see here to the left, the colorful part, the green is yes, the red is no, and the blue is I don't know. And you see that in 2021, Congress participants had mainly not published the preprint. The reasons, but a few of them did have done so. The reasons for not doing it was to a great extent not knowing how to do it, or what we worded here as lack of training. The reasons for doing it was mainly dissemination. You see there are also other motivations here. People were quite much more optimistic about doing this in the future. Mind you, these were questions asked ahead of the workshop, so they were not influenced by the workshop. And we also asked people why they thought others would not publish, have not, or were not using this option. And interestingly, the question of fear of plagiarism became a much bigger issue when you think about why your colleagues are not doing this than when you think about why you yourself are not doing this. So why should you publish a preprint? It's a way to get early feedback from colleagues, though do not raise your expectations too high for getting this feedback, because most preprints are not commented on. It is actually, in contrast to the fear of being scooped or of plagiarism, it is a way to get a timestamp on that you have done this work long before, or sometimes it's long before it's being published because of the time peer review takes. It is not very complicated, especially not if you use a journal that allows you just to tick a box, and when you submit the paper to the journal, it automatically goes to bioarchive or any equivalent server. And it also gives increased access to your research output, because once you have published this preprint, it's out there, it's accessible for anyone. You can update it, and there you have a sort of a way of giving open access to your work. Study pre-registration, another measure, and now we're taking a step back in the chronology of a research process, because the study pre-registration is when you register the study and analysis plan. So it's a plan for what you're going to do in an established registry before starting data collection. There are two main ways of doing this. Pre-registration itself, it is simply, quote unquote, the registration of the plan as presented by the research team, and no one gives feedback on that, you just upload it. The registered report, in contrast, is a real publication. So you submit it to a journal, it's subject to peer review, and after review and revision, the plan is published. Without pre-registration, which is still the main way we do things, the study plan itself, or even the fact that you are doing the study, will not be known until you present the results. And this has implications for transparency, for reproducibility, and evidence of the reproducibility crisis is drawing attention to these issues. So Emily Sena here is quoted to talk about too many drugs, too few medicines, the translational failure of animal research. And one of the arguments that she presents, and she presents data on this, is the publication bias. So the many papers, the many projects, the many studies that are done that are not being published means that we get a biased view of the results. If you have published, if you have pre-registered, there is at least a possibility for someone to trace back how many of registered studies actually translate into publications, and allows us to quantify how much is actually being lost. The other aspect of this is the methods for analysis, and here we have the concerns coming from psychology of very low possibility to replicate studies, and possibly not the suspicion necessarily that the people cook or fabricate their data, but perhaps that there is not enough detail in methodology, and that methods of analysis are being tweaked as you go, as you already have the results, all issues that are problematic for reproducibility. Pre-registration is becoming the norm in psychological science, which I think is very interesting for us to reflect on, because after all, many of our methods are not that different from the methods in psychology. So if this is important in psychology, it's probably important for us as well. Let me see how I'm doing for time. If I had started my chronometer, I would have known. I did just very briefly mention how you do pre-register, but I'll spend some more time on the detail. The registered report is actually, for anyone who's published, is the easiest one, because it's just like any other publication. You simply don't have the results. So that's a section you leave out. And you have to discuss not your results because you don't have them, but what kind of results you could have and what the implications of these would be. So you need a journal, obviously, that accepts registered reports. And when I checked yesterday, Animal Welfare does not do that at the moment, but perhaps that's in the cards. But there are presently around 300 journals that offer it. Most of them are psychology journals, but there are a number of generalist journals, such as the one listed on the slide, where one could publish ethology, animal welfare research, registered reports. Pre-registration is a bit of a different process, so it will be a new process for any of us. You need a registry that is appropriate. You have to write up your work or your plan, and then submitted according to the instructions for that registry. An important difference here between the registered report and the registry is the registered report will become public. With the registry, there may be a grace period, and you may decide when this is becoming public, so you can protect your plan. Animal-specific registries, there are two. Preclinical trials does not sound appealing to anyone who doesn't do biomedical research, but I think they would accept any animal research. Then there is Animal Study Registry, which is a more appealing name for us, I think. These are were both launched around the same time, 2018, 2019. And there is also the Open Science Framework. They also have the option for registering, doing a pre-registration. We asked ISAC conference participants about pre-registration, and this was even less used than preprints. But in the same way as for preprints, people were more optimistic about using it in the future. And again, the main argument for not doing it was not knowing how to do it or lack of training. So why pre-registering? For me as a researcher, it would oblige myself to be more rigorous about my planning and think through all my methods before I actually start collecting the data. It is a contribution to a more open and collaborative atmosphere, especially for registered reports, where you can benefit from peer review at a time when the study plan can be changed. This was really what my dream when I got the first peer review back on my first paper was, what if I could have had these comments when I could still do something about how I designed the study and collect the data. It can also give you a publication to show for at an early stage, and we've used this. I use this sometimes when we move into a new topic for a grant application. Having a registered report is a way to show that we know how to do this, even though we haven't done it yet. For the general quality of science, obviously, the overall greater rigor, preventing deviations from planned analysis, preventing publication bias, or at least giving us an insight into it. The more open and collaborative atmosphere is good for all of us, though, of course, this depends, all these aspects of the general quality of science depends on how widely the practice is actually being implemented. The last aspect of open science that I will speak about is open data. Open data is data that can be freely used, reused, and redistributed by anyone. So it means giving other people access to your data. Asking this in our questionnaire, this was actually the practice which was most implemented by the respondents. More than half of them have sometimes done it, and another quarter do it always. Most likely, I would say, because a number of journals will require that you share your data at the time of publication. Because when we asked people if they know about the FAIR principles, it turned out that they don't. So the majority of those that have actually, or lots of people of those that had shared data, do not know the main principles for sharing data. The FAIR principles are findable, accessible, reusable, and interoperable. And this is what is essential for the data to be useful for others, for there to be a real point when you're sharing the data other than fulfilling the requirements of the journal. If it is for other people to use it, it's obviously essential they can find it. It's essential they can access it. And it's essential that they are allowed to reuse it and that they can understand your data in a way that makes them able to operate on it and not only yourself. So if this is all so great, why are people not using it? Is there a backside to the open science? I will reflect on the potential backsides, which I think is probably part of the reasons, in addition to not knowing how to do it, why people are not doing it. Preprints, is there a risk of getting scooped? You published your work, someone else go and do it. You could, it is probably not a great risk for most of us, because for most of us, the kind of studies we do take a lot of time. You need a unique, often unique access to animal populations. So it's more of an issue for my biomedical bench research colleagues than I think it is for us. Could your work attract attention at the wrong time? And here, a word of caution, yes, it can. If by the wrong time you think, you consider before it has been accepted, before it's been through peer review. It is tremendously fantastic to have Science magazine be paying interest in your research, but we would very much have loved this not to happen the week after we have submitted it, and rather for it to happen when the work was accepted, because it took a year for this work to eventually get published. We had to do, again, because the science journalist will trawl the archives for interesting stories. Dog training is super interesting. The journalist is not interested in our attempt to say, but this has not been peer reviewed, so we cannot comment on it. So then they would write about it without your comment. So we had to do a press release on something that was not yet accepted for publication. So we are not repeating this with dog training data, but lots of work is obviously doesn't have that issue, but I think lots of animal welfare work probably does. Pre-registration, time is an issue. Time is an issue because it takes time to prepare this. That time, I would argue, is an investment in the quality of your work. Though if you go for a registered report, perhaps you don't really have the time to do that bit of the writing before you start doing the study. That is a possibility, and sometimes you're pressed for time. Recognize that. Open data, same thing. It takes time to prepare your data for sharing it. Again, that is well invested time. I don't know about you, but for I have been doing research in this field for about 25 years. Cleaning, decluttering my office, I've thrown out lots of old data because I don't understand that data anymore. And if I had prepared that for sharing so that someone else would be able to understand it, that data would be available to me still if I wanted to go back and look at it. Confidentiality obviously is something that we need to pay attention to. If there is an interest of others that we need to protect by not sharing our data. And I'm sure we would all be aware of the confidentiality of our own intellectual property interest in sharing the data as well. Next steps, I would hope not to give this talk again, but to have some new things in the future. We are right now running on analysis of open data practice in animal behavior research, which hopefully will be done by the end of this year. And we would like to continue the discussion of how we can promote open science practice in our field. And I would be, I think the question and answer session after this talk could be a way to start this. So thank you very much for your attention. And here is reading if you want to read up on this or share with others. Thank you.
Thank you, Anna. Do we have any questions? There's one from Peter.
Thank you. I share many of your views. I'm a bit worried about the preprint. I don't know if you've seen the statistics of the number of papers being published. It's just going completely berserk. You have a world where people write and don't read. And I see a real risk of this, even more of this, oh, my stuff is already out without being ready, because people already can't bother to read all the stuff that they ought to read. So we'll see a big danger of this actually perpetuating a bad culture of everything going so fast. So that's my only worry. I fully agree about the data, and luckily all journals, good journals, all those I publish in now, will never allow me to publish anything with all the data being there. So that's been solved, but I'm really worried about this preprint culture.
I agree. I agree. It is the aspect that I find least appealing to myself, and I do get frustrated when people share a preprint on Twitter, because I sort of want, where is the list for it where I can sign up to get to know this paper when it's actually been accepted, because lots of things happen. Papers get better. I do believe in the process of peer review, and generally it works to make our work much better. The open data practice by journals is good for transparency, but it is lousy for reusability of the data, because they are in a place where you can never find them unless you read the paper. So that's its addresses part of the issue. It doesn't address all of it.
We'll take one last quick question.
Thanks, Hannah. Lovely talk and very useful. And I also support preprints. I worry about pre-registration though, partly because some of the work never gets done, but mainly because I think people are also using it defensively to ring off their area so that nobody else does it. And that, I don't know if there's any evidence for that, but it seems to me that in some areas of science, that's something that does happen or might happen.
Yeah, I don't really know that, but I can see that this could be obviously an issue. I don't know if it's a real problem if stuff is pre-registered and never done, but perhaps there should be a mechanism for sort of saying, well, after a given period of time, this is free again. I have to admit, we have a registered report from 2021 of work that we were not able to get funding for and therefore not been able to done, which is very frustrating, but it's not really our fault, I think.
Thank you very much, Anna. Thank you.
Thank you.
And our last speaker of today is Alexandre Azevedo, if I pronounce it rightly. We are now going to hear about Iberian Lynx.
There we go. Good morning. Thank you for the opportunity to share this presentation with you. My name's Alex, and I'm a veterinarian. I've been working with captive wild animals for 20 years. And to complicate things a little bit further, we do something which is we take wild animals into captivity and then we breed them and then we release their offspring back into the wild. So then this complicates everything a little bit further. And that's what we're going to discuss. So why do we do these things? Whether for the intrinsic value or the services that ecosystems provide to humans, it's generally accepted that we need to preserve biodiversity. But these interventions usually bring forth conflicts between our conservation goals and the welfare of individual animals. And in the case of the Iberian Lynx, this actually happens. So in the conservation world, the recovery of the Iberian Lynx is an international milestone. It's one of those projects that we're really proud of and that gives us hope that we can achieve a sustainable future for everyone and that wild animals can live with people and everything can work. But it starts at a very, very dark point where we had less than 200 lynxes left. There are actually 64 adults, the estimate was. And just to give you some context, in the case of pandas or cheetahs, we're talking about populations with 1,000 animals, 3,000 animals at their worst case. And in this case, we were below 100 animals. And once the conservation efforts start, around the year 2000, we see a steep increase in the populations in the wild. And we're very happy with the results. And it's really an example of success. But this success comes at a cost. And in this case, we're going to look at the animal welfare costs of this success. So in order to achieve this success, many lynxes are spending their lives in captivity. And they face welfare issues due to the proximity to humans, due to the restrictive environments. And this is even worse for those lynxes that were born in the wild, and we brought them into captivity to be founders of the conservation project. So there are measures in place to mitigate these welfare impacts, environmental enrichment, promoting positive bonds with keepers, all sorts of husbandry protocols to try to make things better. Even all the monitoring we do is tendentially non-invasive, clinical monitoring, behavioral monitoring, So there's a huge effort to minimize the welfare impacts. But then there's also welfare impacts on the cubs that we reintroduce into the wild. They're born in a captive environment, and then they're released into a hostile environment where they don't have our help and care, and where they need to survive, breed, hunt, and it's not easy, and many of them die. So to attempt to mitigate these impacts as well, we have a set of measures in place, which include a preparation for these animals before release. They're prepared for release, the ones that are going to be reintroduced. There are different types of releases. We can release them first into soft release enclosures in the reintroduction site, and then open the gates and after habituation and let them leave. And then we monitor them and intervene if necessary, sometimes with supplemental feeding, or if there's an injury or disease, we can or not intervene according to the situation. But then there's the need to prepare these animals for reintroduction leads us to another welfare concern related with these projects, which is the welfare of the rabbits we use to feed them. So in order to be able to release lynxes that know how to hunt into the wild, those lynxes need to learn how to hunt live rabbits, which is their main prey in the wild. So then live rabbits are used to feed these lynxes, the ones that are going to be reintroduced, okay? And in the best case scenario, an adult and capable lynx will quickly kill a rabbit with a bite to the neck. So catches a rabbit and the rabbit dies. It's really quick. However, in the case of little cubs, it's not that quick. And many times the cubs have a hard time managing to kill the rabbit. The rabbit stays alive and injured for a long period. And then there's also another behavior that takes place, which is the dams capture the rabbits, injure them, and present them to the cubs injured. And then the cubs engage in play behaviors and predatory behaviors, and they start exhibiting those behaviors with an injured rabbit. Okay. And in these cases, the rabbit can stay injured even for a longer period. So this is a timeline of one of those episodes from a video surveillance recording. So the dam approaches the rabbit, and about 12 seconds after she approaches the rabbit, she bites the rabbit and leaves the rabbit lying down, injured, but alive and struggling. Okay. It's quite graphic. And then at 19 seconds, the first cub engages and starts clawing at the rabbit and biting the rabbit. And then around 40 seconds, cubs 2 and 3 engage as well. And then about 2 minutes later, the rabbit dies, okay, or stops moving. Well, we can't really say when it lost consciousness or when it died, but at 120 seconds in the video, the rabbit starts moving. So during this time, there's potential for pain, breathlessness, fear, all sorts of suffering for this rabbit. And this period can vary with episodes. It can be shorter and it can be longer, but in many occasions, it lasts more than a few minutes. To be fair, the people working in this conservation project, there's extreme care and there's extreme concern for rabbit welfare and for lynx welfare. And in the case of rabbits, there are protocols set in place to try to mitigate these impacts as much as possible. So there are protocols for how these rabbits are transported, when they're sourced, for how they are housed, how they're handled, and there's a preference to use them dead whenever possible after adequate stunning and slaughtering. And even when they're fed live to the lynxes, they're introduced into the enclosures in these really complex and expensive systems of artificial warrens where they have abundant refuge and resources. And I think it tranquilizes the people to have an idea that the rabbit has a fighting chance, but it also signals a huge concern for the welfare of these rabbits. And at the time when I was working on this, whenever anyone on the staff asked me, are we doing everything we can to assure the welfare of these rabbits? I was fairly certain that we were. I was convinced that we were. Looking at the legal situation, looking at the applicable laws, Iberian lynxes are protected from capture, holding, sale, and transport by the Berne Convention for conservation of European wildlife, but the convention doesn't mention welfare, pain, or suffering. The Iberian Lynx conservation action plans, which are also published in law in Spain and Portugal, also do not mention pain, suffering, or welfare in any situation. And in the case of the rabbit, only regulation regarding the farming and the transport apply until it enters the conservation center. Okay. Once it enters the conservation center, there's no applicable regulations in the European Union. The conservation project, however, does seek guidance in other regulations. For instance, the regulation on keeping wild animals in zoos, animals kept for farming purposes, animals at the time, protection of animals at the time of killing, and also during transport, and tries to apply the guidance that exists in those regulations. But otherwise, for the context of conservation specifically, of conservation interventions, there's no applicable regulation. So in conservation, our decision usually to use these animals, and I use the word use intentionally, to use animals for conservation purposes, usually the decisions are made based on a consequentialist approach where we weigh the benefits of this use against the harms of the use, okay? And when I came into contact with in a training in lab animal science with Anna, it was striking to me that this is kind of the way that we do things in biomedical research as well. We weigh the benefits to humans, production of medicines or whatever results from the research against the harms that we do to the animals. And in conservation, we're not really weighing this formally yet, the welfare impacts on individual animals, but the approaches kind of fit. So the question we're going to ask today is, what if we crossed boundaries between disciplines and topics and applied this science and education framework to our example of Iberian Lynx conservation? What would our project look like? So project evaluation would basically follow this approach. And based on that consequentialist weighing of harms and benefits, we would probably deem that the use of Iberian lynxes is necessary for the benefit of human health and other animals, other lynxes, other rabbits in the ecosystems, other species, and the environment. The harm-benefit analysis would be performed, but while it was performed in the conservation project based on extinction risk, so we weighed the harms and benefits of taking a few lynxes out of the wild into captivity and what the impacts could be on the wild population, but it was only based on extinction risk and on the ecological consequences. In this case, if we followed the science and education framework, it would need, one of the criteria would need to include the welfare of the individual lynxes. And then there'd be a suite of legal welfare requirements focusing on methods to minimize the suffering of these lynxes and on the competence of people to apply these methods and to execute these procedures. And this would be applicable to keeping the animals, to breeding the animals, and to using the animals. We would need to consider the principle of reduction. So we need to ask the question, what's the minimum number of lynxes required to achieve our conservation goals? Once again, this was done, but this was done because of the individual ecological value of each lynx. So if we had 100 lynxes, one lynx was 10% of the total population of the world. So this was carefully weighed and this was carefully assessed, but not based on welfare concerns, based on ecological concerns. So this would be done as well. And then we'd need to consider the principle of replacement. Can these lynxes be completely or partially replaced, particularly in the phases where suffering is more likely? We need to think about, for instance, if we're going to translocate genetic material, different lynxes from one population to the other, could we be moving semen only instead of maybe moving actual animals, and then we'd avoid the impacts of changing the environment. And this, in the case of the lynx, this is already being done based on welfare concerns and also logistic concerns. It would be easier if we could just use artificial reproductive techniques to manage these populations genetically. And then finally, we'd need to look at the principle of refinement. Can alternative practices minimize or mitigate lynx suffering? This is already done as well. We can obviously, environmental enrichment that we use in the conservation projects falls under this category, but we perhaps need to look a little bit further and think about whether captivity or the safety net population that we have in captivity can look differently at some point in the future. And for instance, be based on biobanking and not live animals. So we need to look at this in the long term and have a plan. In the case of rabbits, would be quite different. Although the justification for use would probably also be deemed necessary, the rabbit use would be deemed necessary for the protection of human health, animals, and the environment. The harm-benefit analysis would be performed, which in this case was not. At the current scenario, under the current framework, there was no harm-benefit analysis performed for the rabbit use. And probably rabbit welfare would weigh heavily in this analysis, and it would be probably be the main criteria. There would also be a set of legal requirements, legal welfare requirements regarding the methods, competence of the personnel, the choice of the animals. Perhaps we could think about whether wild rabbits or naive farm rabbits are different in the way they are impacted by this use. And we'd also need to think about that. Reduction, obviously, the principle of reduction. What is the minimum number of live-fed rabbits that is necessary for a lynx to acquire the hunting skills to survive in the wild? We assume that they need live rabbits, they fed live rabbits, but we have domestic cats that have never been fed live prey and that exhibit predatory behavior and hunt. So we don't really know the answer to this question, but we definitely, in the conservation project, we do have the setup to be able to look into this. So we need to think about these questions, which right now, up till now, we didn't. I didn't think about them when I was working on the project, never crossed my mind. And then replacement as well. Can live rabbits be completely or partially replaced by dead rabbits, lures or decoys, particularly in these phases where there's more suffering involved, like when the cubs are very young, when the dam is presenting rabbits to the cubs? What are the determinants? What triggers those behaviors? Are they visual cues, auditory cues? Is it the movement? Is it the smell? Can we use pelts or decoys to replace the use of live rabbits? At least some of them, perhaps in some stages. We don't really, once again, we don't really have answers to these questions, but now we have questions if we look at it from this framework. And then finally, refinement. Another example would be, could it be different if we brought the lynxes into a rabbit enclosure as opposed to putting a rabbit into lynx enclosures? Would a stable population of rabbits mitigate or help them cope with the impacts of predation when it occurred? So in conclusion, current European Union frameworks do not regulate the welfare of animals used in conservation. Guidance is often sought in other regulations and in other frameworks like farming, transport, slaughter, and zoos. But the ethical approach to the use of animals for conservation is analogous to the one used for scientific and educational purposes. And the principles that guide animal use for scientific and educational purposes could apply to conservation. When we did this exercise, applying it to the Iberian Lynx example, it highlighted notable opportunities for improvement that we didn't, within the project in our previous paradigm, identify. So from a conservationist perspective, the questions we need to be asking is how to establish a framework that can find a balance, strike a balance between these environmental goals or environmental concerns and the welfare of individual animals. How can we find a framework that can accommodate this pluralist view that we've been talking about and avoid polarization, establish limits for the harms that are acceptable, and bring everyone to a reasonable position. And also the other question that results is, as conservationists, do we want to take the lead on this change, or do we want to wait for social pressure to make us move? So I'd just like to acknowledge all of the incredible people who have basically saved this species. And thank you for your attention. And I'd love to hear some comments and thoughts.
Thank you. We'll take one short question.
Wow, short. Sorry. Alex, Juan Darras, Book PR from Brazil. Wonderful talk. Thank you. Is there a light at the end of the tunnel? So looking at the curve that you showed at the beginning of our presentation, I saw that the growth is kind of like fits where the growth curve of a population that is put in place where there's plenty of resources, right? So I assume at some point this population should get to a point where conservationists will agree that you don't need this program anymore. So that's one thing. So is that this light at the end of the tunnel for you guys? And then have you considered this thing on like, should we speed up all this whole project, so causing a lot of suffering for a short period of time to get to this point quick, or slow it down and with less suffering but for longer? So that's kind of like a framework that
you can answer one of those.
Yeah, I'll maybe answer the last one, which is most related to the topic. So whether it's better to do a lot of harm really quickly or, for a prolonged period, we need to weigh that case by case. But the thing is, we need a framework that establishes limits to harm and makes us look at the harm. At least I think we're just, a step behind still. We need to get there, and we need to make that change to actually look at these harms, establish limits, consider them these welfare harms, because at the moment, it's driven basically by environmental values, which is, it's the purpose. But I think in order to avoid polarization and to, find the best way forward, we need to actually find a framework that considers both environmental values and individual animal welfare.
I'm going to allow one more question because Bjorn has been cut off so many times.
Thank you. I think we all agree that minimizing suffering is a good thing. First thing. Second, conservation, I think, is different from other approaches in that you're letting the animals out in the wild. So you're presenting rabbits to lynxes in an enclosure, and you're saying you should minimize that. And then you're letting them out, and they're eating rabbits outside of the enclosure. So isn't the real question here, are you doing this not for the animals, but for your own satisfaction? I mean, the ethical concern, so to speak, is not to minimize animal suffering, but rather to feel good. I've done what I could.
Yeah, I would extend, I completely understand your point of view, and I would actually extend that feel good and agree to society as a whole, okay? Because these projects depend on public funding, and they depend on social acceptance and social license. So yes, I would say it has to do a lot with how we feel about doing things. And I think that is where the use of animals for science and education has found a way to stop polarization or to minimize it by putting limits to the harms, whatever they are, but putting limits to the harms that can be shaped to what social norms are at each time.
Please help me thank all of the speakers for this morning's session. We now have a break for refreshments for 40 minutes, so please be back here for starting at 11:35. Thank you very much.